So components or in some restricted endpoints, maybe as low as 30, but not below that. So that is a requirement for QSR. So we should to take care of a narrow range of endpoint values. If the endpoint values are so that they do not span over a wide range of log values, then we are unable to develop statistically meaningful models. So at least 4 to 5 log unit span is required. Excessive number of not just calculation, lack of spelling may problem during interpretation of statistics. Most of the models are generated by non-mathematicians, non-statisticians, so the misinterpretation of statistics should be avoided. Consideration of distribution of residuals give us idea about the type of error present in the model on the system. Inadequate training test selection, that also is a problem. The test set should not be very small, because in that case the metric that you generate will be biased. Failure to validate the QSR properly and mechanistic interpretation should be there. Now, many of the points that I have mentioned here are based on statistical modeling approach. So QSR is a statistical modeling building approach. So we have to comply with some of the requirements. Like say we should have this sufficient number of data points. Like it should be like 50 number of compounds, and we should not use many descriptors because the model that will be generated will be statistical. So we have to comply with this requirement. So what happens if we have some data, but if we want to comply with all the requirements of meaningful model, in those cases the predictions will also be unreliable. But we need to have some kind of prediction. So in those cases we cannot use QSR because we are unable to apply with those requirements with the sufficient number of data points. Division of the data points into training and test, because if we divide into training and test, we lose much of our information. The training set will be small, and that will not have sufficient number of data points to convey information to the model. So the derived model will not be robust. It will not be properly trained. So if we are unable to generate QSR for prediction purpose, it may so happen that we may use some alternative approach, which is not a statistical fitting approach. So the requirement of statistics may not be there, and we are able to predict our endpoint. So we may use some kind of prediction for untested compounds, so that fills the data gaps. So as you know, some kind of prediction is better than no prediction, because we must have some kind of data. Especially for regulatory purposes, for toxicity prediction, etc. Say some novel chemical or some data point of interest, some polymeric data or some nanomaterial for which no toxicity data has been generated experimentally. If we want to have some kind of information about the toxicity profile, we can use this kind of alternative approach, where we cannot use QSR, because for QSR we have to use a sufficient number of data points. We need to generate training and test for validation purpose. We need to have different kind of metrics satisfied with the calculated values. So if we are unable to do all those things, if we are able to generate QSR, then it's fine. But if we are not able to generate QSR, then we need to use the alternative approach, and that alternative approach may be read across, where we can have prediction without using statistical approach during prediction, but after prediction, we can validate our data using our similar metric like R-square paired or Q-square external F1 or F2, etc. But once we get the prediction, we are able to calculate those kind of metrics. So QS is not suitable for small data sets. If we have a small number of compounds, maybe sometimes say 10 or 15, we cannot generate QSR meaningfully. So it will be discarded actually, this because we may have important descriptors, 4 or 5 descriptors, but only 10, 15 data points. So that is not meaningful. So that will be an overfitted model. So that will be discarded. So we have to use alternative like read across. So read across is not a statistical fitting approach. Calculation is comparatively easier than QSR. One can easily predict it. Predict a data endpoint for the query compound. This is an alternative tool for hazard assessment in data gaps. So data regulation for export of chemical and the toxicity data should be experimental, but if experimental data is not derived predictions, or it can be with read across derived prediction. Do not have sufficient number of toxicity data for nanomaterials, especially for nanoparticles. So we have usually data taking a 3D or human characters. So we use generative data across. So objectives of this particular work that I'm discussing here, method for quantitative read across predictions, quantitative prediction of small of metal oxide nanoparticles. Here, that I discuss here is toxicity of metal oxide nanoparticles, but it can be used for other kind of toxicity prediction, toxicity of some other hazardous materials, or it can be used for screening the naturally occurring compounds also. Comparison of the results with previous methods that we have done, and development of an application for read across, which is available via the web. So here we have used 3 different data sets. All of them were used previously by other methods. The first data set is PLC50 of metal nanoparticles against human keratinocyte cells, cell line. And here, as I mentioned, all of these were previously used. We have used same descriptor information as used in the previous case, that is the electronegativity of the cluster and enthalpy of information, and the number of data points was 18. And the second data set is PEC50 value of metal nanoparticles against bacteria E. coli. Here the risk structure and charge of the metal cation corresponding to a given oxide. Here the number of data points was 17. And data set 3, that is PLC50 of metal nanoparticles against bacteria E. coli under dark condition. Here also we use the and additional one another this particular descriptor. But here the descriptor is not important for us to understand the algorithm. Here we will discuss about the method by which we derive or we get the read across predictions. As you can see, the number of data points in all the cases was very low, 18, 17, 16. And although these data sets were previously modeled using QSR, but you can understand these QSR predictions are not reliable because of low number of 3 data points. In 3 cases, number of data points was less. So what is then 20? So what we have as we have to show some kind of, in each case, into 2 parts. We'll use the term source compounds. We have one series that is source compound, and the other is target compounds, and we have tried to divide 50%. So 50% of the compounds were taken in the source compound, 50% of the compounds were taken in the target compound. So in case 8, we have 18 data points. We have taken 9 and 9 like this, and we have used 3 similarity calculation method using kernel functions. One is Gaussian count